So right now we are standing at the contact between Samanasuk. On my right side and my left side you have this green sand, Glauconitic rich sands of Chichali formation of early Cretaceous. So you see you have this carbonate succession dominantly comprised of oolitic shoals and other coated grains, oncolites and piezoids, dominantly ooids, along with some bioclast and some other features of marginal marine setting or tidal flat settings. You have mud cracks and all these features preserved in these carbonates. And suddenly that carbonate platform drowned in the late Jurassic early Cretaceous. People call this Chichali formation is early Cretaceous, but we have dated this unit, and previously it was dated based on ammonite. You have some late Jurassic succession present in the lower part of the Chichali formation, and then this dominant green sand is deposited during Valanginian time, Berriasian Valanginian time. So this that's the important location for demarcating the Jurassic-Cretaceous boundary, which is quite controversial because this boundary keeps varying in different sections of the world, and that's why so far there is no standard type section of this boundary. But here you are in the Baroch Nala Surga range, part of the Trans-Indus ranges, Eastern Tethys, located in Pakistan. It's a beautiful section where you have this transition from the carbonate lithology to this clastic dominated green sands, and it is belemnite as well. So there is one anoxic event during Valanginian time. It's called Wyset anoxic event. That's also probably somewhere located within this unit, but you need high resolution biostratigraphy in order to confirm its stratigraphic interval along which this boundary is present. We have published some palinophytes and dinoflagellates from this unit, but the resolution of the sample was not very high, so we couldn't actually demarcate it. We couldn't demarcate the Wyset anoxic event. So you see we have these belemnites. One of the most important feature of these green sands of early Cretaceous in Pakistan, and these belemnites are in the form of temphestites. You see, you have this graveyard of belemnites. You have multiple cycles of belemnites, and these mass, you cannot say extension, this mass mortality is repeated time and again within this green sand. You see, when you go upwards, so you have these temphestite beds there. So probably during early Cretaceous, the sea level fell at the boundary between these Jurassic carbonates of Killovian age, because in lower Indus Basin you have these laterites building on top of these carbonates. So there is unconformity, and then you have the sea level rise, and when sea level rise in its initial stage, so you have the dominance of the wave activity and wave and storm activities, and that's why probably you have these temphestite beds of belemnites depositing along these boundaries. You also have some ammonites preserved. You see ammonites preserved along with these mortality horizon, mass mortality horizons, and then you have this green stuff, and then in the Aptian Albian time you see this white quartzo sandstone that represents the Lamshiwal formation. That means that sea level start falling, and you have this massive deposition of the Lamshival formation, which is white quartzose, very clean sandstone as compared to this glauconitic sands. And then the sea level start rising again on top of the Lamshival. You have Hangu, and then Hangu, you have a lot of coals, and coal definitely represents a swampy setting which is associated with the sea level rise. So on top of this white sandstone, you have the Hangu, where the coal is extracted in different regions in Pakistan from the Hangu formation. And then you have the typical nodular limestone, which represents the skyline, and that's a limestone which represents establishment of late Paleocene shelfal carbonate. And then when we go further, so we'll talk about the various Eocene shelfal carbonates along the way.